Hello and welcome once again for another EE 340 video. This one's going to be an example problem, the first example problem for day 3. And um, this one we're going to be dealing with convection, so heat transfer rates through convection. So a fan forces air over a computer surface, a computer circuit board with a surface area of 70, this should have been centimeters squared to avoid overheating. The air temperature is 300 Kelvin, while the circuit board is surface temperature is 340 degrees Kelvin. Using data from table 2.1, determine the largest and smallest heat transfer rates in watts that might be encountered through this forced convection. So just as a note, we might not have discussed this yet, but as a note, watt is equal to joule per second. Basically, when you take that derivative with respect to time, you're going to end up getting end up getting units of per second in there, which is why we get a watt rather than say joules. Um, and so this is obviously an energy transfer rate. Now, if you remember from the class video when we were discussing this, the has a constant H. That constant really depends on the scenario, the situation. The table 2.1, so we can actually see what those scenarios might be. So we have free convection. So this is our H value. We have free convection in either English or SI units. Free convection of gases, free convection of liquids, free forced convection of gases, and forced convection of liquids. So let's go back to the problem and see what scenario we're looking at here. This is specifically stated to be forced convection, and it's air that's being forced over. So air is a gas in any form of scenario one could imagine, pressure-wise, pressure and temperature-wise. So, um, sound, we have forced convection of gases, which means that H is somewhere between 25 and 250. Okay? So if we go back to the problem, it's asking us to determine the largest and the smallest heat transfer rates. So let's first look at the equation, and then we can start drawing conclusions here. So the equation from the textbook that we get for convection is Q dot is equal to H times A times T of the body minus T of the fluid. Okay, and obviously the um, only thing that we have to be concerned with now is what is the temperature of the body, which is the board surface in this case, and the temperature of the fluid. Notice that the body temperature is higher, implies that Q dot C is greater than 0. So that means that the min will come at H equal to 25. Let's get the units because I don't remember it off the top of my head. Watts per square meter times Kelvin. And the max will come at H equal to 250 watts per square meter times Kelvin. Okay? min will come at h equal to 25, and the max will come at h equal to 250. By the way, if this had been negative, that actually would have, right? Because minimum is a negative number, in magnitude negative number is smaller than a smaller in magnitude negative number. So it would have flipped this around. But because this is going to end up being positive, that's what we can conclude. So QC min is going to be equal to 25 watts per meter squared times Kelvin times, well, we have 70 centimeters squared. But the problem is that we need the, notice that this is in meters squared and this is in centimeters squared. So we need to do a conversion. So recall that 1 centimeter is equal to 10 to the minus 2 meters. And that means that 1 centimeter squared, if I square both of these things, is equal to 10 to the minus 4 meters squared, because 10 to the minus 2 squared is 10 to the minus 4. So that means that this is going to be multiplied times 10 to the minus 4 square meters per 1 square centimeter, which obviously means we'll get these units canceled out here. And then these units will cancel out, which is going to be nice. And then the final thing is the TB minus TF. Well, that's easy enough. 340 minus 300 is 40. So times 40 Kelvin, which is equal to 7 watts. And then obviously QC max is going to be similar. It's going to be 250. And since 250 is 10 times 25, it's just going to be 70 watts. Okay? So that, because that was the only thing that changed in that calculation. So we get 7 watts as a min, 70 watts as a max. That's all I have for this video. I hope to see you again soon.